We're now going to talk about dilations, but this time from the y-axis. Now, these tend to be the more confusing of the dilations. So let's begin by just writing down what it would look like in our function notation. We know that when we're dilating from the y-axis, that means we've got this. So we're timesing the x by the k here. Now, what this tells me, now this is where people normally get freaked out a little bit. This is telling me that we're dilating by a factor of not k, but the reciprocal, 1 on k, from y-axis. That's what it's telling me. So you have to remember to take the reciprocal of it. We spoke a lot about that when we spoke about transformations and dilations and all that later on. Okay, if we look here, as you can see, that if I was to let x be equal to 1, I would get 3 out here. But after I dilate by 2, now what is this saying? This is saying that we're dilating by a factor of a half. So that means I'm taking my x value, because there's a half from the y-axis. So that means my x value is being affected, and I'm timesing the x value by a half. So instead of 1, I get a half. Do you see how it's dilating from the y-axis in this case? It's kind of getting closer to the y-axis. That's what's happening here. So this is a dilation from the y-axis. It tends to be the more confusing of the dilations. So just make sure that you have an understanding of what it means to dilate from the y-axis. All right, I'll see you in the next one.